right. So today we're talking about the fundamental forces, and there are 4 of them. We've been talking about one of them thus far, that gravitational force. Remember that gravitational force happens with all objects with a mass. It is an attractive force, which means gravity will never take you away from something. The second type of fundamental force is called a weak nuclear force. This is going to be what's responsible for nuclear force, like radioactive decay, what we do in those nuclear power plants, Chernobyl. What was the one in Japan? Huh? No, that was something. I was talking about the plants, not the other stuff. Not the stuff that we're not going to talk about, even though today is the anniversary. Yes, today is Pearl Harbor. Yes. Today. Fukushima. Thank you. All right. The third one is the strong nuclear force. The strong nuclear force is going to be what holds the atoms together. And then the one that we're going to go into today is going to be the electromagnetic force or electromagnet. Or electrostatic is sometimes what it's called. This occurs between all charged particles. Okay, this electrostatic or electromagnetic force occurs between all charged particles. It can be attractive or repulsive. So as a refresher over where this charge comes from, we got to go back into an atom. Remember, in the middle of the atom, you have a nucleus, which has protons and neutrons. All right, so the charge of an atom is Q. C's already taken, so we had to use Q. Okay, so Q is charge, and typically I write it lowercase, but I'm trying to get better about writing it uppercase because people say my Q's are funky. You
should write it on the side.
It just said that it looks like some weird symbol, not a Q.
It looks like the infinity sign in the angle.
Yeah, so. The charge of a proton is 1.6022 times 10 to the negative 19th coulombs.
Is that a Q?
See? Yes, it's my Q.
Where?
This is a Q.
Oh, I thought that was a 9.
Is that a negative 19?
I never heard of that.
That's a negative 19, yes. Alright, so a coulomb is a unit of charge. And we use the big C. This is why we can't use C for charge, because it is the actual unit. Coulomb is the unit of charge. Coulomb.
Just think of Columbia. Wait, no. What? It sounded better in my head.
Yeah.
G-O-U-L.
It's spelled towards the bottom of your paper. And then we also have in the atom, or really on the outside of the atom, we have these electrons. On the outside, they are negatively charged. And I don't know. I'm sorry, guys.
Say outside.
I'm quitting. Outside.
Is that Brandon was mentioned at the beginning of this?
Yes, it is. I completely read that as outside. Outside does have a T in there. Thank you. So, electrons also have a charge of Q equals 1.6022 times 10 to the 19th coulombs. The difference is that electrons, that's a negative charge. Protons, it's a positive charge.
Okay, I promise. Never mind. I got it. Never mind.
All right, so an ion is a charged particle. When it has a positive charge, that means it lost electrons. If something has a negative charge, it means it gained electrons. We cannot mess with the protons inside. So your charge depends on your status of electrons, and that's it. This should all be reviewed. All right, opposite charges repel or attract. If you're opposite.
They repel.
They attract.
Wait, what?
Opposite charges attract. Opposites attract. Like charges repel.
Oh.
Like a magnet.
I got it.
Ow!
All right, so
Think about it like that. Or like a magnet. You're right.
if you're a positively charged particle, your electromagnetic charges, if you could pause it and visualize it for a second, would look like this. So all the arrows are pushing out. Draw it. So again, if you're positive, which I showed that with a plus sign, all the charges are pushing out. If you're negative, they're opposite. So all of that force and all of that energy is going to be going in.
Can you go back to
Yep.
positive drawing?
So when you get two of the same charge, they do not like that. And what happens is they're going to push each other's stuff kind of away from them.
By any chance, was Columba a dude or a person?
Coulomb? Yes.
Dude.
Huh? He did electricity.
Where's he from?
Yeah, that's
Ooh,
what I
maybe France?
So we think alike.
All right, when you get opposite charges near each other, they like that. And so now everybody's happy. Everyone see the difference between those two?
Yes.
Oh, wait. All right. Coulomb's law says the force between two charges depends on the magnitude of the charges and the distance between them. And these are my cursive cues, guys. I'm so sorry.
Those are good.
F is equal to K times the Q times Q over the radius between them squared. Okay, this should look very similar to the equation we've been dealing with all week with gravity. The difference here is my K, I had what was it? Oh, big G. Now we have big K, and it is, it is another one, but it is 9 times 10 to the 9th newtons per meter squared over coulomb squared. Big K.
Okay.
Big K. Like the big K. Okay, reminder, constants do not change. That's why we call them constants. So for example, it says what is the wait, forgot, sorry. Oh sure, I do not. Right there. Do not.
You should start teaching like that. That's helpful.
That's helpful.
It gets our attention.
If I used it too much, then it wouldn't be helpful.
Sorry, say that again?
Ow.
Do not use signs in the equation. Okay, what do I mean by signs?
Negative, positive.
Don't use negative and positive. As far as this equation is concerned, everything's going to just be positive. The only time you need the signs is when you need to find out if they are coming together and they're attractive, like positive, negative, or if they're repulsive. They don't like each other. Positive, positive, negative, negative. Otherwise, I don't want to see like negative 2 times positive 3 here. Okay? Do not use the signs in this equation. So it asks, what's the electrical force between a proton and an electron and a hydrogen atom that are 5 times 10 to the negative 9 meters apart? Is it attractive or repelling? If you have a proton and an electron, are they attracting one another or repelling one another? Attractive. Because the positive and negative. I gave you the charge of them earlier, so we're going to write F is equal to big K All right. That charge of that proton, I gave it to you earlier, is 1.6022 times 10 to the negative 19th. I will never ask you to memorize something like that. That's a gross number. You will not have to memorize it, but I did give it to you earlier, so that's where I'm pulling it from. This one. It's a small number, actually.
Even if you multiply it to the 10th, negative 19?
That times 10 to negative 19 means that there are... Oh, let me say this number for you.
There's a lot more spaces at the end.
Hold on. It is 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 0 0 0 0 0 0 0 0 0 16022.
So it's not a big number, it's just a long number.
It's a long number, it's a small number.
So long, small number.
Long and small.
So are those like the two ones that
That's these are my charges from up here. Okay, because again, protons and
I can't listen to them try or what?
okay, and then they have a distance of 5 times 10 to the 9th. -9 on the bottom.
Do I know what country to you?
All right. This would be how you set this up. This is still calculator work though.
Oh, really?
All right, when you multiply out the top, you should get 2.56 times 10 to the -38. I'm going to divide it by the bottom. I'm going to make sure that's squared. And that's where I'm at right there. That's not my answer, but I'm going to let you catch up.
Wait, you did that?
So I multiplied this times this, and then I divided by this squared. Watch your parentheses. Make sure that you're not trying to square the entire answer.
You did 2 parentheses?
I do. I don't trust the calculator. I don't trust nobody.
Wait,
I
so
don't
who do
even
you
trust myself most days.
You just said no one.
So you don't trust anything, anyone, nothing.
No,
So
this
trust
is
isn't
just
even a word in
that.
your vocab.
It is. It's I don't trust.
Wait, I got .102.
That's a good word.
So I got 102 times 10 to the 21st. -21.
102?
All right, that is not my answer. Now, that is what my parentheses equals. So now I need to times it by my k.
9.0 times 10.
9 times 10 to the 9th. Got 9.2 times 10 to the -12 newtons. This is a hard example. We're going to do some easier ones.
That's it?
Yeah.
That's not hard.
What's your n times n squared?
Huh?
What's your n times n squared over c squared?
Those are my units. That's a unit. All of that,
Wait, so where did you get this?
all of this right here, that's a unit of that constant. Hold on.
Where'd you get the 9?
This 9?
No, the one where your time.
It's the K. K equals.
Oh yeah, that's my K. Y'all don't have to write this. Like, I would say don't write this because it's going to mess up your notes. But, Emily, look. This is newtons times meters squared over coulomb squared. This is C times C, so this becomes coulomb squared. This is in meters squared. So C squared cancels out, M squared cancels out, and you're left an N. So all of this mess right here is just units.
Oh, okay.
And you end up in newtons because it's a force. Again, I didn't want you to write that down.
You said what?
Don't write it down. All right. Practice.
Your
Wait. Oh.
I set this one up right,
You have some?
and it's a big number.
Should be 9 times 10 to the 9th.
That's
All right. A point charge of 4.3 times 10 to the -6 coulombs. It's 0.003 meters from another charge of 4.5 times 10 to the -6 coulombs. Find the magnitude of the force. Remember that magnitude means number. F equals K.
That was no water.
All right, when you write this all out, it should look like this. Okay, calculator work. (4.3 times 10 to the negative 6 times 4.5 times 10 to the negative 6 should get you that. Everybody get that?
Yes. And then you divide it, right?
I divide it by 0.003 squared. Notice I'm using that in parentheses because if I just put divided by 0.003 then squared outside of that, it could square my answer, and that's not really what I want it to do. So I'm left with 2.15 e to the negative 6. So 2.15 times 10 to the negative 6. So that is what all of my parentheses is equal to. Now what do I need to multiply it by? Okay. So 9 times 10 to the 9th. Keep in mind it's actually 8.98 or 8.98 I think. So we're just rounding up. But and I get an answer. Are y'all with me so far?
A little bit. Like,
Yeah.
A little bit.
I'm at like 10.
10%. Okay.
Then how do you know if it's attractive or repulsive?
These are both positive numbers.
So they're repulsive.
They are repulsive.
Alright, if they're both positive, they don't attract. What's that word?
Repulse. Repel.
Repel.
Wait, so what do
But
you
if they're positive and negative, they attract.
I multiplied
Think
everything
of
by
it as like
K.
this, as a magnet.
Yes.
After I divided,
Yeah, after you divide it by
I multiplied it by K. Alright. This next one is about as hard as it gets for these, okay? The first thing you'll notice, and I bolded it because I'm a nice person on the inside, very, very deep, deep, deep down. Very deep. 5 centimeters is not the right unit.
Needs to be 5 underneath or
0.05 meters.
so you do 9 times 10 to the negative 3 twice.
Hold on. Two like and equal charges are a distance of 0.05 meters and exert a force of 9 times 10 to the negative 3 newtons on each other. Find the magnitude of each charge. Okay. Do this in pencil. My phone, man. Someone get that, please.
Hey, that's R2D2.
Yes.
Go get them.
The phone? Yeah.
The phone. The phone is ringing.
You actually thought that was.
I thought that was Star Wars.
That's Wonder Pets. Hold on, guys. Hold on.
That was supposed to be in the Monday.
Edit this. All right. So when I write out this is my formula, and I've written it out. Now it says F equals 9 times 10 to the negative 3. So I'm gonna take my F, and instead of writing F, I'm gonna replace that with that 9 times 10 to negative 3. Okay, and my R is equal to 0.05. That's squared. I know my numbers suck in size. That's squared. It's not 052.
Wait, what was under there? R?
It wasn't R. Now it's a 0.052. Y'all have a good day.